Today we're comparing apples and oranges and pitting printers against each other that you would never expect to compete. But why?
Generally, in my review videos, I don't really like comparing printers to each other. I think that each printer should be examined individually and in detail. However, I've started to get a lot of questions like this, especially after the U1 and i7 reviews. Should I buy the U1, the A1, or the P2S combo? Or should I choose the A1 or the Spark X i7? Which one should I prefer? As questions like these increased, I wanted to make this video. While making it, I also kept the scope a bit broad. I also included enclosed printers, industrial type, and desktop industrial type printers in this so that the topic wouldn't be limited only to these or to color printing. I wanted to provide information on how you can find printers that suit your intended use as well. That's why, as you can see here, there is also a desktop industrial class printer. There is also a standard enclosed printer. There is also a printer that we could call semi-open or semi-enclosed, but which stands out with its color printing features. There are also entry-level open frame printers. Even though you see printers here with very different intended uses, there are certain points where they overlap and share common features that can influence people's decisions. For example, what are these? Color printing. All of the printers you see here are capable of color printing. Although, even though I couldn't put the AMS system or the CFSE light system on the table here because they no longer fit, I have made color prints with each of these printers, for example. I will show you the test for this. Of course, one of the things users care about is the budget. What is the budget range for these printers? Okay, I want to buy this printer, but its print quality seems better. Should I maybe stretch my budget a bit more and get this one? I want to make color prints. How much waste do these printers generate? What is the impact of this on my budget? How much electricity does it consume while doing this? Or am I going to use this at home or in my office? Silence is important to me. How loud or quiet do these types of printers operate? It's perfectly natural for us to have questions in our minds beyond just the intended use like these. I want to answer all of these questions. Now we're going to start talking about the features of the printers you see here. While discussing their features, we'll also mention which intended uses they are suitable for or not. Apart from that, reviews for each of the printers here, except for the P2S combo, are available. If you need more detailed information, you can find these videos on the channel. I'll also be adding their links in the description section. Of course, the video won't continue like this. Let me tidy up here first. After that, let's start the video with the features of the printers and their intended uses. First of all, I assume you've already determined your intended use. Don't start looking for a printer right after this. Research the filaments as well. Which filaments are suitable for my intended use? And what types of 3D printers can process these filaments? Because you can't use every filament in every 3D printer. For example, let's say you've determined that you need an industrial-grade 3D printer. You're going to use ABS and ASA in this printer. For you, having an enclosed case will be largely sufficient. But you want to go beyond that as well. You need high-end engineering filaments such as PA, carbon fiber reinforced PA, polycarbonate, or PPS. At that point, just having an enclosed case on the printer won't be enough for you. For example, let's take PPS as an example. To process this material, the bed may need to reach 120 degrees, and the nozzle may need to go up to 330 or 340 degrees. And H2D is a printer that provides exactly that. Because its bed can heat up to 120 degrees, and its nozzle can reach up to 350 degrees. Even this alone may not be sufficient in some cases. Again, for PPS, your printer also needs to have a heated chamber. The H2D also features a chamber heater that can reach up to 65 degrees. H2D is a printer with dual nozzles. This means that if we want, we can also use support materials on it, support filaments. Some of these are filaments that dissolve in water. For example, if you create a complex structure, it might be difficult to reach the supports. It's possible to print with a water-soluble support material. Or there are also support filaments that can be easily broken away. With the H2D, you can print all of these. As I said, please don't think of this only in terms of this specific printer. You can also look at other printers with the same features. On the Bambu side, there's also the H2C. It's a printer with even more nozzles. It uses a system called Vortec, and you can use up to 7 nozzles at the same time. Again, Bambu has the H2S, which has similar features. When we look at the Creality side, the K2 Pro and K2 Plus models are also printers with similar features. The Bambu Lab P2S is an improved version of the P1S. You could say it stands somewhere between the X1 Carbon and the P1S. As with the other printers I showed, you can already print with PLA, PETG, and TPU since it has an enclosed structure and its bed can reach 110 degrees and the nozzle up to 300 degrees. ABS and ASA filaments can also be used with this printer. Filaments like polycarbonate may be somewhat borderline. Filaments like PPS, which require a heated chamber and higher nozzle temperatures, cannot be used with this printer. Again, if we talk about other printers with these features, as I mentioned, the P1S can be given as an example. On the Creality side, the K2 is one of the printers similar to this structure. One of the most popular printers of recent times is the Snapmaker U1. Of course, there are several reasons why it is so popular. One of them is that it has a multi-head printing system. Thanks to this system, we can print in color with almost no waste. Another reason is its price. Actually, Snapmaker is not the first company to introduce this technology. Previously, Prusa used the same system in its X-large model. However, in my opinion, its price was a bit beyond being affordable. Snapmaker, on the other hand, is much more competitive at this point. Since it is open at the top, I can't say it's directly suitable for engineering filaments. However, it can be made suitable. I reviewed this printer and also showed how the top of the printer can be covered very simply. Yes, after covering the top of the U1, it is possible to work with filaments like ASA and ABS. However, I can still say that this is not the primary purpose of the printer, and it may be much more suitable for those who want to produce by printing in color. You are looking at two printers that are very similar to each other both physically and in terms of hardware. One of them is Creality's new printer, the Spark Xi7. The other is Bambu Lab's A1 model, which has now become a legendary classic. Previously, we knew that engineering filaments like ABS and ASA could be used in enclosed printers. Therefore, you cannot use engineering filaments like ABS or ASA in the A1 or the i7. Open frame printers are not suitable for this. In some cases, they can be enclosed, but this also comes with various risks. For example, if the internal temperature rises too much, it can cause some of the materials used to deform. At this point, we're taking a short break in the video for a brief announcement. Actually, I'm not speaking English right now. In fact, I don't even know English, but thanks to Heygen AI, on a powerful artificial intelligence tool, I can deliver my video content to you in English. In fact, if I wanted to, I could even start speaking Spanish right now.
Quizá debería abrir un nuevo canal de YouTube para mis publicaciones en español.
Or maybe in Japanese.
日本人ってテクノロジーの面ですごく進んでるんじゃないの？もしかしたら新しい YouTube チャンネルも日本語でやるのもありかもね。
If you also want to publish your content globally like I do, you can use Heygen AI, which provides dubbing support in more than 175 languages. Let's pick up where we left off. Or if certain electronic components that need ventilation are enclosed in a box and the temperature rises, this can also lead to dangerous situations. So the main purpose of these open frame entry-level printers is to use materials like PLA, PETG, or TPU. If you ask me, open frame entry-level printers are for those who want to learn this technology, or if you are a parent, you want your child to learn about this technology. Of course, since there are hot and moving parts everywhere, if your child is below a certain age, it should be under parental supervision. These printers can be preferred by those who want to teach this technology to their children, for hobby projects, for making colorful prints, or for producing small items to earn a little income. Especially since their prices are generally lower compared to enclosed printers, I find these types of printers to be a logical first choice. Now we've come to perhaps the most anticipated part of the video, and that's the color showdown. Actually, before I started doing these tests, this was the part I was most curious about as well. What did I pay attention to while conducting these tests? First of all, I kept the speeds the same. All of them were printed at speeds between 200 and 300 millimeters per second. Apart from that, I also limited the volumetric speed to 18 cubic millimeters per second. In other words, I tried to equalize the conditions as much as possible so that there would be no different effect on the duration. Other than that, I didn't touch any of the other settings. So I didn't make any adjustments like extruding less filament or more filament to clean the filament. Again, I didn't interfere with the prime tower settings provided by the slicing software. First, I want us to take a look at the print quality. Let's start with the H2D. When I look at the model overall, I don't notice any issues or problems. Even though it's a highly indented and protruding model printed at high speed, there isn't any significant vibration effect on the surface. The color transitions are extremely neat. There are no uncleaned residues at any point, nor is there any contamination during the color transitions. I want to continue with the same order. I was going to say let's move on to the P2S after the H2D, but as you may have noticed at the beginning of the video, the P2S, unfortunately it let me down both times. I started the print. The print started with the first shorter model. Everything was going really well. The surface quality was also extremely good, but after a certain point, the prime tower detached from its place. Of course, as experienced 3D printer users, we don't give up as soon as the prime tower falls. We try to put it back in place to stick it somehow, and that's exactly what I did. First, I tried to secure it with my hand to see exactly where the prime tower was supposed to be. Then I found the spot and taped the prime tower there. Even though I used pretty strong tape, metal tape, heat-resistant tape, it toppled over again after a while, and at that point I said, that's it. I mean, I can't save this print any longer. From this point on, a really bad result comes out, because when there's no prime tower, all sorts of random waste starts sticking to the model. This seriously affects the quality in a very negative way. I thought, okay, this could have happened. The prime tower could have toppled over on the H2D or on the U1 as well. Honestly, I expected more from open frame printers. In some cases, they can't quite adjust the Z-axis properly. Even micron-level friction can topple the prime tower in certain situations. So I thought that could be the reason. I started the second attempt. Everything was going well. This time, the print reached a higher point. Again, there was no problem with the print. I was quite satisfied with the surface quality and color transitions, but then the prime tower toppled over again. As you can see on the tower, at first I found the right spot again, though with a bit of misalignment. I reattached it. For a while, I continued the print by supporting it with my hand. But after a while, it rubbed against something again. The problem started happening again. I tried to reinforce the adhesive, supported it with my hand again, but unfortunately, no matter what I did, I couldn't succeed, and the prime tower collapsed once more. Of course, dear friends, now, well, the prime tower has fallen. That means this print is left as it is. Well, this also goes against a real test scenario. Why would we just leave our print like this? Wouldn't we try to save it? We would. And I did try. I wanted to give an example from real life. Look, I'll try to show you up close like this. First, I applied some adhesive under the prime tower. After that, I carefully taped down all of the outer edges, using heat-resistant tape. I'm trying to save it. At first, it skipped a layer or two like this. But as you can see right now, it will print the prime tower and then continue the current print without any issues. Honestly, after the second print, I gave up too. I mean, even if I hadn't given up, my filaments did, because I didn't have any other filament in the same color left. I specifically wanted all of these to be printed with Creality Hyper PLA anyway. I didn't want to switch to another filament. I wanted to see both the color change and the print quality with the same filament and the same speed settings. After using up so much filament by the kilo, as I said, I didn't want to continue printing anymore. I mean, put yourself in my shoes. Even if it's a test video, you'd say, oh, well, I won't print it completely. There's some issue with the machine. You'd start trying out other models as well. So when it didn't work out, I left it like this too. Honestly, it was a big disappointment for me. I was expecting higher performance, a smoother performance than the P2S. Otherwise, even though there was no problem with the surface, it made me deal with issues. After that, I switched to the U1. I can't say that the print I got with the U1 was very different from the H2D. The surface quality, just like with the H2D, is extremely successful. In areas with indentations and protrusions, the vibration effects are so minimal that they can be ignored. When we take a close look at the color transitions, again, we can see that there are no residues and that even in very small areas, the transitions are quite smooth and clean. Of course, this is not a surprise for the U1. After all, there are 4 different heads and each one has a designated color. Therefore, since there is no need to clean the color by retracting the old filament, loading a new one, or cleaning the nozzle tip, it was expected that the color transitions would be quite clean. Now, let's move on to our entry-level color printers, the A1 and i7. I can say that both prints turned out quite well. There really aren't any major differences between them. Honestly, if these prints weren't compared to the results from printers like the H2D or U1, I wouldn't really have much to criticize. However, after seeing better ones, I did notice some minor details on these. For example, when I look at the i7, there are some tiny gaps in the chest area of the Ninja Turtle. Here, either the flow rate was a bit low, or the speed I set pushed the printer a little to its limits. On the A1, there is no problem at the same spot. However, I can say that I encountered more vibration issues than I expected from the printer. Especially when I look at the head area, the effects of vibration are very clearly noticeable. This is also present on the i7, but not as much as on the A1. If you ask me, for hobby purposes, the results of both prints at these speeds are at an acceptable level. However, if you need something better, that's when you would need a printer like the H2D, or if the U1 had worked properly, probably the P2S. Of course, color wars are not just about print quality and color transitions. For most of us, the more important aspects are the amount of waste and the print time. Let's take a look at these results in a comparative way right away. We start with the H2D first. The waste filament produced by the H2D in this print is a total of 437 grams, of which 153 grams is the prime tower, and the print time is 31 hours and 30 minutes. We're looking at this theoretically. However, if the P2S had been able to complete a successful print, it would have produced a total of 633 grams of waste filament, 107 grams of which would be the tower. And again, theoretically, it would have completed the print in 50 hours. When we move on to the U1, here there is only a 100-gram tower. Other than that, since there is no nozzle cleaning, it doesn't produce any waste. However, it can be said that a few more grams of waste filament are produced at the beginning of the print for flow calibration. The print time, on the other hand, is only 15 hours. When we look at the A1, here the total waste amount is 537 grams, with 111 grams of that being the tower, and the print time is 48 hours and 30 minutes. On the I7, the results are a bit lower. With 100 grams being the tower, the total waste amount is 471 grams, and the print time is 46 hours. I'm sure you were also curious about what kind of result would be obtained if the Bambu Lab H2C had been included in this color battle. I was curious too, but unfortunately it wasn't very easy to get access to the printer. Still, I wanted to include the H2C in this ranking, at least theoretically. When I look at the data I got from the slicing software, I see that with the H2C, there will only be a waste tower weighing 116 grams. Other than that, there won't be any waste. Because it already has 7 different nozzles, there is no waste generated during nozzle cleaning. As for the print time, it's slightly behind the U1 at about 20 hours. Here, of course, we've actually compared printers that are very different from each other. For example, the H2D and the P2S, yes, they both use the AMS2 light, but this one has dual nozzles. This one has a single nozzle. The H2C is a completely different story. If you look at the U1, which has 7 different nozzles, and say the I7 and A1 are similar because they both have 4 print heads. One uses AMS light and the other uses CFS light. These also work a bit differently. Their extruder systems are also different from each other. That's why I think this gives us some small insights into which system is more efficient. Of course, this is valid for just a single scenario. So, it's not the case that you'll get similar results or results of a similar ratio with every color print. Depending on the structure of the object and the frequency of color changes, these ratios can increase or decrease. Of course, there's another point of curiosity, and that's electricity consumption. Especially after the U1 was released, this question came up a lot. There are 4 nozzles, a lot of print heads on this printer. Each of these heats up and cools down. People started to wonder if electricity consumption would be 4 times higher, and suddenly we were talking about the power usage of 3D printers again. Okay, we've learned about the amount of waste in the prints and how long they take. So, if you ask how much electricity these printers consume in an hour, in a scenario where I assume there are 4 color changes per layer, the H2D's hourly electricity consumption was 0.19 kilowatt hours. In the same scenario, the P2S consumed 0.12 kilowatts, the much anticipated U1 consumed 0.18 kilowatts, the A1 consumed 0.09, and the I7 consumed 0.1 kilowatt hours of electricity. I'm not mentioning specific figures here, but you've learned the print durations and seen the amount of waste. Now you also know how much electricity they consume. Therefore, regardless of time, you can now calculate much more precisely based on the price of electricity in your area or the cost per kilogram of the filament you use, and if cost is an important criterion for you, you can choose your printer accordingly. Another factor that may influence your preference is whether your filaments need to be stored in the open or in a closed environment. For example, in systems like the AMS2 Pro, AMS, CFS or CFS Lite, your filaments are kept inside a closed box. This provides you with advantages such as protecting the filaments from dust or moisture. In printers like the A1 or U1, however, the filaments are kept out in the open. What kind of disadvantage does it cause if the filament absorbs moisture? First of all, your filament becomes more brittle because it has gone stale. You may encounter problems such as nozzle clogs, roughness on the print surface, stringing, or detachment from the build plate. Not every filament is immediately affected by moisture. For example, PLA is actually not a filament that is easily affected. Especially if it is stored in a closed box with silica gel, you can use PLA for many years. However, let's say you are using PA that is nylon filament, you printed something one day and then left it out for 2 days. On the third day, when you try to print again, at best, surface problems will appear on your print. Separation from the print bed is also a very likely scenario. Especially if you are going to work with engineering filaments, you will already prefer enclosed printers. Here, closed systems like the AMS2 Pro will also help you, because, for example, the AMS2 Pro also has a drying function. It can dry your filaments up to 65 degrees Celsius. This can be used for PLA and PETG as well. It can also be used for ABS and TPU. After drying your filaments for a certain period and removing the moisture, you can start printing. The only disadvantage is that the AMS2 does not dry while printing at the same time. So you can only start printing after the drying process is complete. On the Creality side, there is no active drying in the CFS or CFS Lite, but by placing silica gels inside, you can keep the humidity inside the box balanced to a certain extent. But I wanted to choose a printer like the A1, i7 or U1. The filaments of these are exposed, so don't think that you won't be able to get proper prints. If you've bought these printers, it's obvious that you'll mostly be printing with PLA. Maybe you can also use PETG and TPU. You need to be a bit more careful with PETG and TPU. So, as I mentioned earlier, if you store them in closed boxes, you can still use them for a long time. However, if you say you're very meticulous, I think you should get a drying device. I've previously used both the single and multi-version models of these. For example, I also have a 4-slot drying system from Creality. It's incredibly useful for me. If you're very meticulous and want to get better results in printing, you might want to have a dryer on hand. One of the important points I see here is the use of TPU, that is flexible filament. If this is important for your projects, you can't use units like AMS, AMS Lite, CFS or CFS Lite. By disabling these, you can use single-color TPU materials with the hanger feed method. Actually, Bambu developed a rigid TPU that can work with AMS, but it doesn't have enough flexibility. In other systems, filament types like 64D, which are not widely available in everywhere, can be used even if not very efficiently. Here, just like with color printing, the U1 actually stands out from the others. The system not only allows us to use many different filaments, but also lets us use TPUs with varying flexibility, and in addition, you can also achieve multicolor TPU prints. And perhaps one of the most important points for 3D printers is, of course, consistency. I mean, of course, we're talking about consistency in a positive sense. For this, I also conducted a test. Yes, it wasn't a very large test, but I printed the same model 3 times from each printer and wanted to see if they produced similar results. I specifically chose a model that also had small supports like this. When I look at the print I made with the H2D, I don't see any problems. There are some minor natural droops where the supports are attached. But apart from that, in all 3 models, the print came out consistently and cleanly. Looking at the P2S, I can say that after the fiasco with those colored prints, it has somewhat, even if just a little, redeemed itself, because it has a very nice surface quality. In fact, I can even say that it performed better than the H2D at the drooping points. It offered me the same quality in all 3 prints. I think the reason why the P2S is better than the H2D when it comes to drooping is related to the fan. Because in printers like the H2D, the hot air inside is constantly circulated and blown onto the model. But here, P2S had developed a new system. It draws in cold air from outside and continuously supplies cold air inside. This gives it an advantage when it comes to drooping. When we look at the U1, I can't say anything different. All 3 models have achieved consistently good results. In terms of drooping, it's no different from the P2S. Because both the top and the front cover were left open during PLA printing, better cooling was achieved. Drooping is also quite minimal. Now we've come to the entry-level printers, starting with the A1. Looking at the surface overall, I can say that I found it quite successful. There are very minor vibration effects. They exist, but I can only notice them now because I'm comparing it to other high-end printers. If I were to examine it from scratch, I would probably say that it has no flaws at all. Out of the 3 prints, 2 produced consistent results, while 1 had a problem. As you can see, a lot of residue has formed on the model. I should mention that this is not related to the printer's settings or stability. Maybe those who use the A1 have also been experiencing this lately. It might be something related to a recent update. As you know, the printer records time-lapse videos with the camera. Actually, I had turned this off. I mean, I didn't want to make a time-lapse video. But I noticed it had reached a certain point. After finishing a layer, the print head moves to the side. The printer takes a photo of it. Then the print continues. While doing this, actually, these imperfections shouldn't have appeared. Because I have made this kind of video with the A1 before and I didn't encounter such a problem. They will probably fix this with an update. But if you are experiencing this problem right now, know that it's a software issue, meaning even if you turn off the time-lapse, sometimes the printer can keep recording time-lapses. I'll say similar things when I look at the i7 as well. First of all three were able to consistently produce the same print. When I look especially at the side of its head, I notice some very slight vibration effects. However, it's not something significant enough to mention as a negative point. Among the printers here, the oldest one is the Bambu Lab A1. The others were released after it. And I can say based on this test that among these printers, which we can call new technology, I encountered the result I expected, and each printer was consistent in its own way. Now, I also want to touch a bit on the slicing software and remote connection features of these brands. Actually, at their core, they are all similar and the same, because their foundations are based on Slicer and Prusa Slicer. Using these softwares as a base, Bambu developed Bambu Studio. Then Orca was released. Creality Print and Snapmaker Orca were developed based on Orca. So once you get used to the interface of any one of these, you can easily use all the other softwares as well. This has become a huge advantage for us users, even if we switch brands. Thanks to their software, we can connect remotely to all the printers we've discussed. All of them also have cameras on them. So even if you're far away, you can monitor your print and even intervene in the settings. At this point, the brand I've liked the most for years is Bambu. It doesn't cause any problems with connectivity and the cameras on their printers generally work quite smoothly. After that, I can say that Creality comes next. There have been significant improvements on the Creality site. I was also receiving complaints from you about connection problems. You were mentioning this in the comments. I too had encountered some minor connection issues. However, significant progress has been made. Now, on the Creality side as well, both the video is much smoother and connection problems have been significantly minimized. Thirdly, I can mention Snapmaker. If you ask me, they still haven't fully solved the remote connection issue because there is some stuttering in the video. Some solutions have been introduced for this and various files have been updated. When you do these things, it works, it gets fixed and all, but I think users shouldn't have to go through so much trouble. However, Snapmaker has already made a significant breakthrough with the U1. I expect that they will continue this progress in terms of remote connectivity as well. I've saved the piece of information that many users are most curious about for the end of the video. That's usually what I do in my review videos anyway. And that is the sound test. In the sound tests I conducted, the H2D is around 50 to 51 decibels and the P2S is in the 52 to 53 decibel range. The U1 is also around 52 to 53 decibels similarly. For the Bambu Lab A1, I measured 51 decibels, and for the Spark X i7, I got results in the 51 to 53 decibel range. Considering these results, I think all of these printers can be used in a home or office environment. However, especially during color changes, the H2D and P2S are a bit louder. After that comes the i7, then the U1, and I can say that the quietest operation is with the A1. Yes, we've come to the end of another video. I especially didn't want to limit this topic to just color printing. Since I was already working with different types of printers and running tests, I wanted to explain what they are used for and help you with your choice. I hope I was able to achieve that. If you've watched the video up to this point and liked it, you can click the like button or support me by leaving a comment. If you have any questions about these printers or the other printers I use, or if there are printers you want me to compare, please write them in the comments section as well. I would be happy to answer them. May your printer run smoothly and your prints be flawless. See you in the next video. Goodbye.